Hello students, welcome to Shri classes. Let us continue lecture number 3, acids, bases and salts. Last time we saw what happens when acids and bases what happens to acids and bases when they come into contact with water. Acids release H plus ions and bases release hydroxide ions, OH minus ions. This is what we have studied. Now we will study the dilution process. What do you think is a dilution process? Simply, mixing of acids or bases in water is called a dilution process. But one important thing in this is, during the dilution process, what happens to H plus ion concentrations if acids are dissolved, and what happens to hydroxide ions, OH minus ions, if the bases are dissolved in water, is what we have to see here. For example, I will just take one example here. See, this is water, and let us say some H plus ion concentrations is already here. H plus ions are there. In this one, something like 2 moles per liter. 2 moles per liter. And this water here is 1 liter. Water. Already H plus ions are there in this one. Therefore, this is acidic solution here, and water is also there. As H plus ions are there, what is the concentration? About 2 moles for 1 liter. That is the concentration of H plus ions. Now, if further water is added to this one, say for example, if further water is added to the same H plus ions, and you add water to the extent that here water will be 2 liters. H plus ion concentration remains same here. H plus is 2 moles per liter. What happens to H plus ion concentration if water quantity is increased? H plus ion concentration is decreased, isn't it? So whether while adding the acids, whether you add more quantity of acid or less quantity of acid makes the difference in hydrogen ion concentration per unit volume. Here my attention of describing this activity is, if the volume of the water is increased, hydrogen ion concentration per unit volume decreases, and this process is called basically a dilution process. So how do you what do you think is a dilution process? See, when acids and bases are dissolved in water, acids or will take bases plus water, okay, the resulting concentration of H plus ions, H plus ion concentration, and here OH minus concentration, ion concentration decreases. Here also it decreases. So when acids or bases are dissolved in water and thereby resulting in decreased concentration of H plus ions in case of acids and decreased concentration in case of hydroxide ions in case of bases, is called a dilution process. So basically, dilution process is, how do you define a dilution process? It is a mixing of acids or bases with water. It is a mixing of acids or bases with water, wherein the decrease in H plus ion concentration or decrease in hydroxide ion concentration takes place, and that process is called the dilution process. So how do you define it? The definition goes something like this: the process in which mixing of acid or base with water which results in the decreased concentration of H plus ions or hydroxide ions is called a dilution process. I hope you have understood what is the dilution process. Remember, because of the dilution, hydroxide ion concentration or H plus ion concentration decreases. Sometimes the H plus ion concentration can be referred to be hydronium ion concentration also, because H plus are not stable, they will react with water to form hydronium ion concentration. So mixing of acids or bases with water that results in the decreased concentration of hydronium ions or hydroxide ions is called a dilution process. One more important thing is this dilution process of acids, especially acids, is highly exothermic here. It is exothermic in nature. Dilution process of acids is exothermic in nature. Therefore, always add acids to water. What is that we say? Always add acids to water. So during dilution process, always we add acids to water. See here, and also that is also with continuous stirring. There must be a continuous stirring. That is also important. We have, and it should be added very slowly. Slow addition of acid. I can write a slow addition of acids with constant stirring enables us to prepare the diluted solutions of acids. Are you able to understand? Similarly to the bases also. So if it is water over here, H2O, then you add acid to this one, okay, very slowly and with constant stirring. Take a glass rod and continuously stir it constantly. So why it should be done here is, the moment acid comes into contact, this acid drops will go inside and the heat developed will be absorbed by the water here. The other way around, this is the right method. The other way around, if I take acid over here and if you pour water, the moment water droplets over here, the moment water droplets come over here, say for example something like this, the moment water droplets come over here, being highly exothermic action, this entire solution may splash out due to excess heat generation. Because of the exothermic reaction, the excess heat is produced. That is also a localized heat. The splashing of the acid may take place, or addition of water into acid may result into splashing of the contents of the beaker, and therefore thereby the one who prepares may get injuries or burns on his skins basically. And therefore prevention of water to acid should be avoided. Not only that, sometimes due to localized heating, due to localized excess heating, the apparatus may break. Very important. The apparatus may break and it may cause injuries and all. And therefore you must remember that always add acids to water. So what is the dilution process? It is a mixing of acid or a base in water that results in the decrease in hydronium ion concentration or hydroxide ion concentration. That process is called dilution. And during dilution process, always add acids to water. Similarly the bases also, but in case of acids, the reaction is highly vigorous and the dilution process being extremely exothermic in nature, always we must add acids to water very slowly with constant stirring. Otherwise it will lead to the splashing of the contents of the beaker, or splashing of the acid takes place that causes burns or severe burns for the handler, and due to sometimes localized excess heating, the apparatus may break and cause injuries to the one who handles the dilution process. So this is important one thing. So next topic in this we'll see. What is common to both acids and bases? Next section in this says, what is common to both acids and bases? Very quickly, both acids and bases behave like electrolytes. What do you mean by electrolytes? Acids and bases release ions. Acids release H plus ions and bases release hydroxide ions. These H plus ions and hydroxide ions, H plus ions and hydroxide ions are responsible for the flow of electricity in liquid medium or in solutions. See, in conductors, in solids, the flow of electricity is enabled by the motion of electrons, by the movement of electrons. That is, the drifting of electrons towards the positive terminal of the battery leads to constitutes electric current. Similarly, what are that are responsible for the conduction of electricity through solutions? Ions are responsible for conduction of electricity through solutions. As acids and bases both produce ions, the movement of ions causes the flow of electricity, the electric current in acids and bases. So, if I take a small experiment over here, something like this, it's a beaker, and here we are taking this is also a cork here. This is a cork. 2 nails can be taken and connect a battery and a bulb and a switch and switch on. Here, if I take, these are the nails here which behave like electrodes, and this is a cork here, cork, and if the solution in this is either acid or a base, in that case the bulb glows. The moment you switch on, bulb glows. Why it is so? Because acids release H plus ions and bases release OH minus ions. The movement of ions takes place inside the liquid, and thereby electrical conductivity is established and the current flows, and hence the bulb glows. Question arises, here the acids contain H plus ions. Does it mean that all the compounds which contain hydrogen ions are able to conduct electricity? Say for example, in one more case, here itself, if I take, instead of acids or bases, if I take glucose solution, formula C6H12O6, or if I take alcohol, ethanol, if I take alcohol, which is CH3 CH2OH or C2H5OH, which is ethanol, these also contain hydrogen ions. But whether these solutions will be able to conduct electricity and the bulb glows, here the bulb does not glow. That means here the bulb does not glow. Bulb does not glow here. Why it will not glow? Because this glucose as well as alcohols, they do not produce ions. Do not produce ions. As ions are not there in the solution to conduct electricity, the bulb does not glow, and hence glucose and alcohol will not be able to conduct electricity. Whereas if I take acids or bases, the bulb glows due to formation of H plus and OH minus ions, and the movement of ions takes place inside the solution, and the movement of ions causes the flow of electricity. If you really want to know a small mechanism how the electricity flows, I just want to explain. If you are interested, you can listen to that. Let me take here itself in this diagram. Say for example, we have a hydrochloric acid HCl solution. This is HCl dilute hydrochloric acid. This is split into H plus ions plus chloride minus ions. These are called cations and these are called anions. The mantra of electrolysis, or the mantra for conduction of electricity over here, this mantra is cations migrate to cathode, cations migrate to cathode, and anions migrate to anode. Anions migrate to anode. Okay, what is cathode and anode? Here this is a positive terminal, this is a negative terminal. The electrode that is connected to positive terminal is called anode. The electrode that is connected to the negative terminal of the battery is called cathode. Okay, here you have in the solution inside you have H plus ions and Cl minus ions. How the electrical conductivity takes place? Cations migrate to cathode, anions migrate to anode. Listen here. What are anions? Chloride ions are anions. Chloride contains excess electrons, therefore it is electron rich species. It migrates to here anode. It will donate an electron. The electron starts moving in this direction. Electron starts moving towards the positive terminal, and again here the electrons comes back and stands over here. The electron is here. Electron. Now cations migrate to cathode. This is a cathode, and this hydrogen migrates towards this one. As hydrogen is electron deficient species, it is seeking for an electron. It migrates towards the cathode, hydrogen, and picks up the electron and becomes a neutral atom. Similarly, in the beginning, chloride being anion migrate towards the anode and it releases its electron, excess electron, and becomes a neutral atom. And therefore the electron moves like this, comes back at the cathode, where hydrogen will be eagerly looking for an electron. So H plus moves towards the cathode and accepts an electron, and thereby this process continues. Understand? As long as the process continues, the releasing of electrons, accepting of the electrons, and formation of the neutral atoms of hydrogen, neutral atoms of chlorine, finally formation of the hydrogen molecule, chlorine molecule starts taking place. It takes place. As long as the formation of, as long as the ions are present, till such time the flow of electricity takes place. Once all the ions are vanished, hydrogen gas will be liberated here, chlorine gas will be liberated. Once all the ions are, when the solutions is deficient of ions, then the flow of electricity stops here. So you must know how exactly the electric current passes through the solution. By means of this principle, cations migrate to cathode and anions migrate to anode. Okay, I hope you have understood. And also one more thing, see here the chloride ion which moves towards the anode releases its electron to the external circuit. Here at anode there is a loss of electron. Loss of electron. What is the loss of electron in case in terms of oxidation and reduction reactions? Already I have explained to you, oxidation involves loss of electrons and reduction involves gain of electrons. Here the chloride ion migrates towards the anode, it loses its electron and becomes a neutral atom, and neutral atoms together, chlorine gas is produced. So at the anode, loss of electrons is taking place and oxidation involves loss of electrons. Therefore, at anode you find oxidation. Please remember, always at anode you find oxidation. What about the cathode here? Cation migrates to cathode. It accepts the electron to become a neutral atom and thereby molecule of hydrogen. Here electron is accepted. That means gain of reduction involves gain of electrons. Here the gain of electron is involved, and therefore for cathode here it is a gain of electron, and therefore this process is called a reduction. So remember, anode oxidation takes place and cathode reduction takes place, and this is the way by the movement of ions inside the solution the flow of electric current takes place. I hope you have understood. So what is common to both acids and bases? The important thing is both behave like electrolytes, both conduct electric current, and the bulb glows. So if I take a glucose solution or an alcohol which are not acids or bases, they will not be able to release ions in aqueous solutions, and hence no flow of electric current takes place and the bulb does not glow here. So this question comes up in the exams. Describe an activity to show that the acids and bases conduct electricity, whereas glucose and alcohol do not conduct electricity. For that question, you have to describe this entire activity. Is it clear? Now I will direct you to the PPT, where in a brief I have written, note down those contents clearly. Okay, fine. Here this is simple. These two activities. This is how the setup is established, and note down these contents and the diagrams. Remember, you will be asked a question to describe an activity to show that acids and bases conduct electricity, whereas glucose or alcohol do not conduct electricity, by giving an explanation saying that they do not produce ions. I hope you have understood. Please note down the contents. Now next, yes, we have completed now the definitions of acids and bases, indicators, chemical properties. Now we will go for salts. What is the definition of a salt and what are the different types of salts, their properties and their uses? Properties, very less properties, hardly few properties. Mainly the preparation of the salts and their applications is very important for your standard. Okay, so let me describe all these things on a board and then I will direct you to the PPT for making notes. Let us study now the salts. Salt is a product of neutralization reaction. When acids and bases react together, due to neutralization reaction, salt and water is produced. So when acids and bases react together, acid plus base gives you salt and water. So definitely it is a result of the reaction between acids and bases, which is also referred as a neutralization reaction. So salt is an ionic compound. It is also referred to as an assembly of ions. It is an ionic assembly or assembly of ions. And important thing is, in aqueous solution, it dissociates into ions. It dissociates into ions in aqueous solution. Now, how these salts are formed? I'll just take one example here. Sodium hydroxide, okay, plus sulfuric acid, H2SO4. Now, here I have two possibilities. This sodium metal ion will replace hydrogen ion from this acid and form a salt. For example, NaHSO4 plus H2O is one product. Is it balanced here? NaHSO4 plus H2O. Let me check up. 4 plus 1 5, 4 plus 1 5, 2H, yeah, it is balanced. This is called sodium hydrogen sulfate. Sodium hydrogen sulfate. How many hydrogen ions are replaced here? Sodium is a metal which replaces one hydrogen ion or one hydrogen atom from H2SO4 to form NaHSO4. One H has gone here, that has mixed with this OH ion. So I hope you are able to understand. Here I can write here NaOH plus H HSO4. See here, this is how the reaction is taking place, and this combines with this. So NaHSO4, this H plus OH combined together is water. That means, can I say here, there are the hydrogen atoms present in the sulfuric acid over here. There are two hydrogen atoms. That means the replaceable hydrogen atoms are two. Here sodium is replacing only partially the hydrogen of replaceable hydrogen atoms in the sulfuric acid. That means sodium has replaced only one hydrogen atom, and therefore sodium hydrogen sulfate is a product formed by partial replacement of metal ion, which is sodium, by this hydrogen ion. So here the partial replacement of replaceable hydrogen atom takes place. Please listen. Partial replacement of hydrogen atom by metal atoms takes place here. Now another example here I'll give you. NaOH plus H2SO4. Okay. Now the product here is Na2SO4 plus water. So let it be 2 here and 2 here. Okay, Na2, this is balanced. So this is sodium sulfate. What happens to here? This 2Na and this 2Na has replaced both the atoms over here, both hydrogen atoms. Here there is a partial replacement of replaceable hydrogen atom. Here complete replacement of replaceable hydrogen atoms. H2, two atoms of hydrogen in sulfuric acid are called replaceable hydrogen atom. So metal atom is replacing partially the replaceable hydrogen atom. Metal atom is replacing completely the replaceable hydrogen atom. So dear students, we can define the salts something like this. These two are salts here. Which one? Sodium sulfate and sodium hydrogen sulfate. These two are the salts. And the definition of the salts can be something like this also. A salt is a compound which is formed by either partial or complete replacement of replaceable hydrogen atoms of an acid by a metal or an ammonium ion. By a metal ion you can say for your standard, or ammonium ion also actually speaking. So what is the salt here? Salt is a product which is formed by either partial or complete replacement, of replaceable hydrogen atoms in an acid by a metal atom whenever acids and bases react together. I hope you are able to understand. Once again, salts are formed by partial or complete replacement of replaceable hydrogen atoms in acids by a metal atom whenever acids and bases react together. So this is how the definition of the salt goes. Okay. Anyway, I will direct you to the PPT at the final, and then you can note down all the details. So you have understood what is a salt here. It is an ionic compound and it dissociates into ions in aqueous solutions. Next, what are the salt families? See here, very quickly I'll explain. Salt families refer to salt family. For example, chloride family, sulfate family, or carbonate family. What are chloride families? Sodium chloride, calcium chloride, magnesium chloride. All these are the salts of chloride family. Sulfate family, Na2SO4, CaSO4, or magnesium sulfate. These are sulfate family of salts. carbonate families, Na2CO3, then CaCO3 or MgCO3, etc. Isn't it? So these are carbonate families. Also you have nitrate families, NO3 families. So CaNO3 twice, MgNO3 twice, NaNO3, sodium nitrate. All these are called nitrate families. So what are family of salts? A particular ion, salts of a particular ion are called salt family. Here these are all chloride family, here sulfate family, carbonate family, nitrate family. These are the different families of salts. Okay, fine. Now, what are the salts that we are studying in your chapter? I will list down the salts that we are studying in your chapter, and then I will go one by one. The salts that are under study, okay, are first one, common salt, and formula is sodium chloride. Chemical name is sodium chloride, common salt, and then you have just a moment, bleaching powder, common salt, then bleaching powder, this chemical name is calcium oxychloride, and third one, baking soda, this is sodium hydrogen carbonate, and fourth one is washing soda, this is Na2CO3 into 10H2O, sodium carbonate into decahydrate, and fifth one, plaster of Paris, this is CaSO4 into half H2O, which is called calcium sulfate into hemihydrate. And of course here also we are studying gypsum, because this gypsum, plaster of Paris, when we mix it water, gypsum is formed. Formula for gypsum is calcium sulfate into 2H2O, which is called calcium sulfate dihydrate. So these are the salts which are going to study here: common salt, bleaching powder, baking soda, washing soda, plaster of Paris. Okay, first I'll take common salt, and there is one more small thing we should understand before I proceed with this one. What is neutral salt, acid salt, basic salt? First we'll study those things, and then I'll proceed to the common salt. We'll take the common salt. What is its chemical formula? What is the common name? What are its uses and applications? We'll study. So first, before studying these salts, let me define what is a neutral salt, acid salt, basic salt, how those are formed. So remember, under salts, first one is neutral salt. Neutral salts are the one whose pH value is 7, neutral. How do you form these neutral salts? How these are obtained? Neutral salts are obtained by the reaction between strong acids and strong bases. So here it is very important: strong acid strong plus base strong will give you neutral salt plus water, but here this will give you a neutral salt. Example, sodium chloride. How do you obtain sodium chloride? It is obtained as a result of sodium hydroxide, acidic hydrochloric acid, which is a strong one, and sodium hydroxide, which is a strong base, gives you NaCl plus H2, isn't it? NaCl plus H2. So which is a strong here, which is a strong, and this is a neutral. Second one, acidic salt. Acidic salt, the pH is less than 7. Because less than 7, it indicates these are acidic salts. Which is a salt here? Example I will give you first. Ammonium chloride, NH4Cl. What are acid salt? Acidic salt is the one which is formed by strong acid and weak base. How it is formed? Acid plus base gives you salt plus water. Salt plus water. Here strong acid, weak base gives you acidic salt. See here, strong acid, weak base gives you acidic salt here. You are able to understand, this is called acid salt or acidic salt. Now example is ammonium chloride. How do you obtain ammonium chloride? Strong acid you take it, HCl. Weak base, which weak you take? See, calcium hydroxide, ammonium hydroxide, all these are weak bases. So you can take calcium hydroxide or something like ammonium hydroxide also. Not calcium hydroxide, ammonium chloride I am giving an example, and therefore I can take it as ammonium hydroxide, NH4OH. You understood? Hydrochloric acid is a strong acid, ammonium hydroxide is a weak base, and therefore NH4Cl plus H2O is formed. Okay, NH4Cl plus H2O. So this is acid salt. Here it is a strong acid, it is a weak base, and therefore acidic salt. Third category is basic salt. Basic salt, example. Which example will take a basic salt? Basic salt, I can take Na2CO3, mild base. Na2CO3 is also called sodium carbonate. It's a basic in nature, sodium carbonate. So how do you obtain basic salt here? Basic salt is weak acid, strong base gives you basic salt. Are you able to understand? Simple here, whichever is strong, that kind of salt is produced. If both are strong, neutral salt is produced. If acid is strong, acidic salt is produced. If base is strong, basic salt is produced. Simple it is as such. So how do you obtain Na2CO3? Na2CO3, for this acid I will use H2CO3. H2CO3 is called carbonic acid. Whenever carbon dioxide is dissolved in water, carbonic acid is formed, which is a weak acid and a strong base. Take sodium hydroxide, NaOH. What is that you get here? Na2CO3. It is not balanced, but for your information, this is how it is formed. So carbonic acid with sodium hydroxide gives you Na2CO3. So very important here, what is that you have to know? Neutral salts pH is 7, acidic salts pH is 7, and what is the pH of the basic salt here? pH of the basic salt is greater than 7. pH is greater than 7. So greater than 7, if the pH value, we already know the substances are basic in nature, isn't it? So you have understood neutral salts, acidic salts and basic salts. Now I will go to the study of salts now. Okay. First one, first salt, sodium, common salt basically. Chemical name for common salt is sodium chloride. Formula for this is NaCl. How do you obtain this one? Main source is seawater. There is also called one more, which is called a rock salt. Rock salt is formed by drying up of oceans. Whenever the oceans dry up, the beds of the oceans will form the salt, a rock salt, and actually this is ocean bed will form into rock salt. Dried ocean bed forms rock salt, and it is in the form of mining. Basically it can be mined just like a coal mine and all, and also it is impure. And therefore its color is brown. So this is a rock salt. Why do we explain rock salt under the common salt is major content will be sodium chloride, but definitely there are some impurities because of which it is brownish in color. And how do you obtain this rock salt is when the bygone oceans dry up. In that case, the ocean beds, after drying up of all the water, the ocean beds are formed in the form of salt, and that is called a rock salt. And how do you obtain that one? How do you get it one? It is just like a coal mine. How the coal is obtained in the mining, similarly this rock salt is obtained by mining here. Okay, these are the things. Now next is very important thing. What are the applications of common salt? Common salt, sodium chloride, it is used in many applications. What are the uses here? It is used in preparation of sodium hydroxide, which is also called caustic soda. Okay, it is used in the manufacturing of chlorine gas, used in the manufacture of hydrogen gas, and obtaining all these three products is by means of chlor-alkali process, which we'll study now, chlor-alkali process. And finally, next, this common salt is used in the manufacturing of bleaching powder, it is used in the preparation of baking soda, used in the preparation of washing soda, etc. Isn't it? So see here the uses of common salt. In one or the other way, we are using the common salt in the manufacturing of sodium hydroxide, chlorine gas, hydrogen gas by a process called chlor-alkali process, and also it is used in manufacturing of bleaching powder, baking powder. This is baking soda, I'll write. Rather than this, it is a baking soda and washing soda, etc. These are the main applications of this thing. So now we'll go for the first one. See individually all these, how these are prepared and what are their uses, we are studying in detail. And under the common salt, what we understood, what is the source, what are the uses, these are the things which you have studied. These are the uses of common salts used in the manufacturing of sodium hydroxide, chlorine, hydrogen, bleaching powder, baking soda, washing soda, etc. Is it right? Now I am taking obtaining sodium hydroxide, chlorine gas and hydrogen gas by means of chlor-alkali process where sodium chloride is involved. Let us study now how to obtain sodium hydroxide. Sodium hydroxide, what is the formula? NaOH. This is obtained by means of a chlor-alkali process. What is this process? It is a process in which electric current is passed through an aqueous solution of sodium chloride, which is also called a brine solution. So it is a process in which electricity is passed through electricity is passed through aqueous solution of sodium chloride, which is also called a brine solution, So what are the products obtained when electricity is passed through this sodium chloride solution? Let us see. NaCl plus H2O. This put together we call this as a brine solution, aqueous solution of sodium chloride. When electricity is passed through this one, electricity means electric current. Okay. What are the products obtained? Sodium hydroxide, which we wanted, plus chlorine gas plus hydrogen gas. These two are the gases that are obtained. Let us balance it. 2 NaCl, 2 H2O gives you 2 NaOH, Cl2 plus H2. 4 hydrogen, 2 plus 2, 4. It is balanced. Now, whenever this electric current is passed through the brine solution, we obtain sodium hydroxide and chlorine gas and hydrogen gas. Why do you call this as a chloralkali process? Because the product formed are alkali, sodium hydroxide, and also chlorine gas, isn't it? Chlorine gas is evolved, and then also the alkali is produced, and hence this process is termed as chloralkali process. Now, very important thing is how this is obtained. Say for example, we have a tank over here. In this one, concentrated solution of brine is taken, sodium chloride plus water is taken into this one, and you have some electrodes. There are 2 electrodes. Suppose this is the solution here. Connected to a battery, plus minus. Okay, so what are these electrodes here? This is anode and this is cathode. And this is a cathode. Sodium chloride is taken. See, what are the ions that you can find over here? What are the ions present? You have Na plus, Cl minus, H plus, OH minus. These are the ions. Water will be split into H plus and OH minus ions. Sodium chloride will be split into Na plus and Cl minus ions. Now, important, in my previous class also I have explained, whenever the electricity is passed through the solution, and if it behaves like an electrolyte, and if the current flows through that one, then the mantra of that is cations migrate to cathode, anions migrate to anode, isn't it? Here H plus is a cation, and therefore it will migrate towards this one. And suppose this is a chamber here, and here, okay, here the hydrogen gas will evolve, H2 gas will evolve through near this electrode. That is, hydrogen gas being positive ions, H plus are called cations migrate to cathode and H2 gas is evolved. Similarly, the chlorine gas or the chlorine ions move towards the anode, and here you can find chlorine gas evolves. Chlorine moves towards the anode, releases its electron, it becomes neutral atom. One more chlorine neutral atom put together, chlorine gas is formed. Similarly, H plus H atom together will form hydrogen gas. Finally, what I can conclude here is hydrogen gas is liberated at cathode and chlorine gas is liberated at anode. This is what you must understand. And also, the sodium hydroxide is liberated towards the cathode here. This is NaOH which comes out. This is sodium hydroxide. You understood? Sodium hydroxide comes out. So it is a small electrolytic cell in which we are carrying out the electrolysis, in which sodium chloride is taken and electric current is passed. Hydrogen gas is liberated at cathode and chlorine gas is liberated at anode. So can I say like this, where this is liberated, you must understand this, where these are liberated. Sodium hydroxide is liberated towards cathode Okay, and a chlorine gas, this is anode, and hydrogen gas cathode. Okay, these are the things. So this is a chloralkali process which is carried out in a cell basically. What else is required here? Yeah, I think that's all. Now important thing is, some of these uses we'll see in the same thing. I'll discuss the applications of chlorine gas, hydrogen gas, as well as sodium hydroxide. You understand here? First I'll list down here the uses of sodium hydroxide. What are the uses of sodium hydroxide? NaOH. What are the uses of sodium hydroxide? It is used as a degreasing agent. Means you must have seen the chains and sprockets in a bike and all, which will be a greasy in nature. By putting oils and grease and all over the period of time, a lot of grease will be there on that one. And if at all it is to be cleaned, say for example if it requires some cleaning and all, how do you clean that one? How do you clean that one? If you have to make them free of grease, then we use sodium hydroxide solution. So this acts as a degreasing agent. It acts as a degreasing agent. First thing. It is also used in the manufacturing of sodium hydroxide. Sodium hydroxide is used in the manufacturing of soaps and detergents. Soaps and detergents. What are soaps and detergents? Soaps are long chain sodium salts of fatty acids. You understand? Therefore, sodium hydroxide is used in the chemical process in order to manufacture soaps and detergents. Degreasing agent in the manufacturing of soaps and detergents. And you have something like paper making also, in paper making industries, and artificial fiber, and it is also used in artificial fiber, in the making of artificial fiber. So these are the applications of sodium hydroxide. Now let me list down the applications of this chlorine gas. I think I'll let me erase this part here. You have understood this diagram. Let me erase this here. Chlorine gas. See, first of all, chlorine, two important things you should understand. Chlorine acts as a pesticide and also it acts as a disinfectant. You understood? Chlorine acts as a pesticide and also disinfectant. And therefore we use these things in water treatment as well as in swimming pools. Water treatment and swimming pools. And what else? In the manufacturing of certain compounds, say for example CFCs. What are CFCs? Chlorofluorocarbons, which act like a refrigerant in refrigerators. And also we use in PVCs. What is PVC? PVC pipes and all, that is nothing but polyvinyl chloride. You understand? It is polyvinyl chloride. So these are the products in which chlorine gas is, these are the applications in which chlorine gas can be used. Let me list down the applications of hydrogen gas now. Here I can write it, hydrogen. See, the main application of hydrogen you find is as a fuel. In the rockets and all, hydrogen gas is used as a fuel. Okay. And also we can use this as margarine. Have you come across margarine? M-A-R-G-A-R-I-N-E. Margarine, it is a manufactured food which resembles in structure and taste the butter. Margarine is a substance which looks like the butter and tastes like a butter, but many people say it is healthier food compared to the butter. So it is used as a in the manufacturing of margarine. This hydrogen is used, and also it is used in the manufacturing of ammonia, NH3 ammonia, which is used as a fertilizer, basically used as a fertilizer. Okay, so these are the applications of hydrogen fuel, manufacturing of margarine, in the manufacturing of NH3, which is used as a fertilizer. So these are the applications of sodium hydroxide, chlorine and hydrogen. Once again, important is chlor-alkali process. Chlor-alkali process, why we are studying chlor-alkali process is we are studying the application of common salt here. You must understand that we are studying the salts. Under that salts, the first one is a common salt. In that common salt, the application of common salt is to produce sodium hydroxide, chlorine gas and hydrogen gas by means of chlor-alkali process. When electricity is passed through the brine solution, these are the resultant products and these are the applications. So the first common salt application is over. Next we will go to second salt, which I will list down now. Second one, it is a bleaching powder. Second, bleaching powder. Bleaching powder is a common name. What is the chemical name? Chemical name is calcium oxychloride. What is the chemical formula for this one? CaOCl2. CaOCl2. So bleaching powder is a common name, or also it is called a commercial name. Chemical name is calcium oxychloride. Chemical formula is CaOCl2. How do you obtain? In the beginning of the salts we studied, common salt is used in the manufacturing of bleaching powder also. So here it is not a direct usage of common salt NaCl, but the product of chlor-alkali process, that is chlorine gas we are using. How did you obtain chlorine gas? Chlorine gas was obtained by chlor-alkali process, in which sodium chloride was used, and therefore here the bleaching powder is produced by action of chlorine gas, Cl2 gas, on dry slaked lime. Slaked lime is calcium hydroxide, CaOH. So let us see here, CaOH2 twice plus Cl2. What is that you get over here? Calcium oxychloride, CaOCl2. What is the other product formed over here? Calcium oxychloride plus water. Is it balanced? 2 hydrogen, oxygen 2, 1, 2, chlorine 2, it is balanced. So this is calcium oxychloride, which is a bleaching powder. I hope you are able to understand here. Very important thing is, how do you obtain the bleaching powder? Action of chlorine gas on dry slaked lime. It is called a dry slaked lime. It is not a calcium hydroxide solution we are taking, but it is a dry here. This is called a dry slaked lime. So action of chlorine gas on a dry slaked lime results into production of bleaching powder. Okay, now let us understand the applications of bleaching powder or the uses of bleaching powder. Let me change the pen now. Yeah. Uses of bleaching powder. First of all, as the name suggests, it is used for bleaching applications. Bleaching of what? Cotton, then linens, then paper or wood pulp, we can say, or wood pulp. Where do you use wood pulp? Wood pulp in paper industries. Paper industry. So it is used for a bleaching action on bleaching of cotton, bleaching of linens, wood pulp, which is used in paper industries. That is nothing but whitening of the wood pulp over here. These are some of the bleaching actions. And what about in domestic application? It is also used as a cleaning agent in domestic applications. It is also used as a cleaning agent in domestic applications. Not only that, in laundries also it is used. Laundries for bleaching. And then you have disinfecting in drinking water. It is used as a disinfectant. It's used as a disinfectant. It is used as a disinfectant for water. Okay. What else? Bleaching, laundries, as a disinfectant for drinking water. Then let me see if any more applications are there. For bleaching of cottons and linens, wood pulp, washed clothes in laundries, and for disinfectant in drinking waters. And one more important is, see, in industries it is used as an oxidizing agent. As an oxidizing agent in industries. Oxidizing agent in industries. What is this oxidizing agent? Calcium oxychloride would be able to provide nascent oxygen for oxidation process, and many oxidation reactions will be there involved in industries, and therefore one of the important oxidizing agents. So bleaching powder is also used as one of the important oxidizing agents in industries. So these are the applications, and this is the manufacturing method. Important in the examinations, you will have both the preparation as well as the uses will be there. Try to remember as many as uses possible, and please stick to the chemical reactions that have been given in the book, and no other books should be referred for the chemical reactions. It is always preferable to stick to the reactions that have been given in your textbook. It is preferable. Okay, so fine. So this is about bleaching powder. Next I'll take up the third salt. Request you to note down some points from these slides. You can pause the video to note down. There is the definition of the salt here. As I was explaining to you, sulfuric acid contains 2 hydrogen atoms as replaceable hydrogen atoms. So here it is partially replaced, only one hydrogen replaced. Here both the atoms are replaced. So these are how the salts are formed. So these are the families you can note down. Next one. Yeah, here also I think you have noted down, just a moment, not this one. Yeah, here the types of salts. I hope you must have noted down these things, I think so. Yeah, why do all acid? I think you have noted down already these slides. If not, note down also. These are types of the salts: neutral, acid, basic. Note down. Here the salts under study which I had listed. From this slide you can note down all this. common salt, bleaching powder, baking soda, washing soda, plaster of Paris, gypsum. These two we are collectively studying, and we have completed common salt and bleaching powder as of now, that you can note down. Common salt, the details. Rock salt, very important, how it is obtained. See, the either oceans or seas, generally oceans refers to it is very large in area. What is the difference between sea and ocean? Seas are small bodies comparatively, or compared to the oceans, you can say. Both are salty water only, but oceans are very large in nature, and seas are smaller bodies compared to the oceans. So the drying up of the seas also leads to the beds of the sea getting converted into rock salt. You can note down that. And common salts applications. Sodium hydroxide chloralkali process. Note down all these details. You can pause the video and note down. Here, chloralkali process, how it is taking place. Important products from the chloralkali process. Important here is anode, cathode, which I have explained very clearly. And when brine solution is taken, chlorine gas is released at anode, hydrogen gas is released at cathode, and sodium hydroxide solution is also released at cathode. And the applications of chlorine, applications of hydrogen, and application of sodium hydroxide written here. All these you must know very well. Along with this diagram, you may get this diagram in the exam. Bleaching powder, how it is manufactured, chemical reaction, and applications. Yeah, I think till bleaching powder we have completed. I request you to make short notes of all these slides. Okay, fine. Yeah, dear students, we have taken today some salts. We understood what are the salts, what is the definition, and then we took common salt, sodium chloride. Then we took bleaching powder, which is calcium oxychloride. But we also studied the production of sodium hydroxide by using common salt, that is chloralkali process, and what are the products of the chloralkali process, and what are the applications of chloralkali process we have seen. So today we'll end the session over here. In my next lecture, I'll be able to complete the rest of the salts. Thank you very much.